formatted, touch it, bring it, fade it, watch it, turn it, leave it, stop formatted, touch it, bring it, fade it, watch it, turn it, leave it, stop formatted, touch it, bring it, fade it, watch it, turn it, leave it, stop formatted.
Okay, guys, welcome back. Today, we're looking at lesson 3.5, learning targets. I can explain the difference between APR and APY. I can also use the compound interest formula, which is a more efficient way to calculate compound interest. Wow, there's a mouthful going there. All right, so let's jump right into it. So first of all, what's important to know is that this whole idea of a compounding interest formula, we did in our last chapter, but we're going to introduce a slightly different way of looking at it today. Well, the reason for that is because of this idea here. Okay, calculating compound interest using the simple interest formula can be tedious because you got to keep adding the interest back to the principal. When there are numerous periods, yet the power of mathematics can turn this long procedure into a relatively small amount of work. Thus, we have the compound interest formula, which relates principal to interest rate, the number of times an interest is compounded per year, and the number of years that the money will be deposited, and the ending balance. And then we have this second thought. We have this thought of a APR, or annual percentage rate, which is your yearly rate without taking into account compounded interest. And then we have APY. All right, now APY actually looks at your effective annual rate and includes interest that is applied in your balance. So real quickly, I found this little diagram to kind of help us think about this a little bit clearer. APR is typically talked about in terms of credit cards and when you're taking out a personal loan. It's the money that you're going to pay out. And included in that is your interest rate and fees and any miscellaneous loan costs. APY, on the other hand, can be thought about the money that you're earning, like interest. And that includes interest rate and generally compounded interest. So those are just kind of quick ways of kind of thinking about the idea and making some sense of it. So here we are. Let's jump right into this compounding formula. So according to the compound formula, what I'm going to do is I'm going to find my principal, and I'm going to find the rate I have. I'm going to multiply that by the number, or divide that by the number of times I'm compounding, and I'm going to go to I'm going to use my exponent operation and use the time and the number of compounds. So let's look at, as an example, Jeff. So Jeff starts with $2,300. And he has an interest rate of 3.13% interest rate. He is compounding once a year. Oh, did I write? No, he's compounding weekly. So what does that mean in our formula? It means we're going to start with our principal of 2,300. We're going to turn our percentage into a decimal, and we're going to put that compounding weekly, okay, into the denominator. So what I have now is the 2,300 is being multiplied by that decimal raised to a power 4. So what is Jeff's ending balance? His ending balance is $2,373.11, which is to say he earned an interest of about $73. Okay, let's get a couple more practice problems. Okay, let's look at example 2. So we have Kenneth Hill Savings Bank, and they're offering a CD that is paying a 3.88% interest rate, and it is going to be compounded daily. Okay, that's a little different. So we went from compounded weekly to compounded daily. Now, what is the effective APY for this account? Okay, well, guys, I introduce you to the APY formula, which we use from time to time. Okay, so in this formula, we have our rate, the number of times it's compounded, that's going to be raised in the exponent of n times the time. So in this case, we know it's 1 year, so that's going to be 1. Daily, compounded daily, that's 365 here, 365 here. This is my percentage. I do the power of the number, and I get an effective percentage of 3.96%. So my annual percentage yield is 3.96%. Okay, so again, APY is generally thought about more of when you're earning or investing money, and APR, I'll make sure I said that right, and APR is when you're borrowing money. All right, let's consider Miss Santaro's example. So she is opening a CD, and it looks like she is depositing $16,000. She expects to get compounded daily interest. She is told about a 4.8% interest rate, and we need to figure out what her APY is. Okay, well, here's our principal. I take that back. Here's our compounded daily, 365. That is also in the exponent. There's our rate or percentage, and we know this is for a solid year. We crunch our power, our numbers, and subtract from 1, and we see that we should have 0.04 something multiplied by that by 4, so that's a 4.92% annual. As I was saying, this 4.92%, which is our annual percent yield. Yay, I got it off my tongue. Okay, I want to go to example 4. Mr. Weinstein has a savings account with a balance of just a little bit more than $19,000. It's paying at 4% interest rate. We are talking about compounding it daily. Now remember, daily, 365 days in a year. And we're looking at 3 years, guys. We're going to do this for 3 years. Okay, so where should the 3 go? 3 goes right here in the exponent. Where should the daily compound, the 365, goes in the exponent here and goes in the denominator? Where's my percentage going? You got it, right here, my numerator. Okay, where's my balance? Where's my principal going? Principal goes right here. So we got our principal times parentheses, and inside those parentheses, I have my percentage over my my compounding. So number crunch. We know that we have to do this for 3 years. That goes in my exponent. So that means I am looking in 3 years to have a balance of $21,660.58. But the question is, how much interest will he earn? Well, here's what I'm going to do. I'm going to start with what I invested, and I want to find out the difference between what I invested and what I now have. And we see that's $2,449.24. All right, example 5. So imagine you have $100,000. You want to put it in an account that's going to pay you 5.9% and you agree to have something that's going to be compounded daily, or not daily, but monthly. What will your balance be at the end of 18 years? So at the end of 18 years, what do we have to work with? All right, let's run the math. All right, here's our principal. Here's our rate. This is the number of times that we're compounding. Multiply, raises the exponent the number of times we're compounding. And last but not least, we're doing this for 18 years. All right, when we put on our graphing calculators in use, what we'll have is $288,000, 463.33. That's not a small chunk of change. That's pretty good. All right, let's consider Danielle. She has a CD at Crosslane Bank. She's going to invest $22,000 in change. She agrees to a 4.55% interest rate. And again, this is compounded monthly. And how long is she, what is her ending balance? And how much interest did she make? All right, I forgot this, 4 years. Okay, all right, so run some numbers. Okay, here's my principal, here's my rate, the number of times I'm compounding it, the number of years I'm investing it. All right, so my ending balance is going to be $26,802 and change. I subtract that from my starting balance of $22,350, and I see that what I've earned in interest is a little bit more than $4,000, $4,452.15. Not bad. All right, for our final example, we're going to look at how much more would $5,000 earned in 10 years. Now wait for this. We're compounding this daily at a 6% rate. And I'm going to compare that to if I was doing this with the same principal over the same period of time, using the same percentage, but compounding this semi-annually. Okay, well, let's run our numbers. So if I'm compounding daily, I know I got 365 as the compounding number. When I'm compounding semi-annually, I'm going to use 2 as my compounding number. Okay, we're both going to be doing it for 10 years. We're using the same rate, and we're starting with the same principal. And we see that compounding daily has a more positive effect in terms of our cash flow than compounding semi-annually, to the tune of $46.57 difference. So we would much better have more money than less money if we're going to do the exact same work. So practice problems is now the moment where we go from here to our practice problems. Practice problems are important because it allows us to actually apply materials. When we apply materials, we make connections. So we got to practice this. Again, learning target is I can explain the difference between APR and APY, and I can use the compounding interest formula, which is a more efficient way to calculate the compound interest. Okay, pause the video, maybe rewind it a few times if needed, and then get started on those practice problems. Remember, 30 minutes of study a day keeps bad grades away.